Hey, good morning. We're going to take a look at 4.1, Day 1, Antiderivatives and Indefinite Integrals, or Integration. So a couple things we should learn is that write a general solution for differential equations and use indefinite integral notation for antiderivatives, and then use basic integration rules to find antiderivatives. All right, so far what we've taken a look at, we've found derivatives. Now we're going to go the other way, if you will. So let's play a little game. I'll give you a derivative of a function, and let's see if you can come up with the original function. So the derivative is f prime of x equals 0. That means f of x would equal c. That's just a constant. Because if you take the derivative of constant, it is 0. Now if I have the derivative is f prime of x equals 5, then that means f of x is going to be 5x plus c. Because if you take the derivative of 5x, that's 5. Take the derivative of c, that's going to be 0. You don't need to add on a 0. So if you have f of x is x, then f prime of x is x, then f of x is going to equal 1/2 x squared plus c. Again, I just want you to think about going backwards. If I derive this, do I get x? The answer to that question is yes. Derivative is 2x plus c, or 2x plus 3, so the original function is going to be x squared plus 3x plus c. Now our last one, the derivative is 6x squared minus 4x plus 1, which means f of x is going to equal x cubed minus 2x squared plus x plus c. Now, anti-differentiation is referred to as integration. It's the second main branch of calculus. The symbol for integration is this little elongated s. Now let's take a look at, let's break this down. So if I integrate f of x dx, f of x is going to be integrand. Variable of integration here is going to be x, because our variable up here, for example, is x. Now what it's going to equal, put the equal sign in there, is going to be your general antiderivative, which is f of x plus c, which is your constant of integration. Now that's what we took a look at up here. We actually integrated this. Basic rules of integration. If I integrate 0 dx, that's just a constant. If I integrate 1 dx, that's x plus c. If I integrate k dx, my answer then is going to be kx plus c. Now, just keep in mind k is nothing more than a constant. Here are a couple more rules you need to keep in mind. If I integrate f of x plus or minus g of dx, you can break those up. Integrate f of x minus g of x. Now, in general, what we're doing is the following. The power rule here is if I integrate x to the n power dx, that's going to equal, what you're going to do is you're going to add 1 to the exponent of n, so it's n plus 1. Then you divide everything by that exponent, and you add on c. That's just a general overall rule we need to keep in mind. Now, here are some examples. If I integrate, let's go ahead and put an integration sign in there. If I integrate x cubed minus 4x plus 2 dx, that is going to equal, now I'm going to add 1 to the exponent. Now I divide by the exponent. Minus. Add 1 to the exponent. The exponent on here is 1, so that's a 2, and I divide by that 2. Plus, I have a constant, so you're going to put an x on the end. And then we always have to add this c, because you know that when you derive c, or a constant, that's a 0. Now what we're going to do is we're going to simplify this. So you end up with x to the 4th over 4, plus, minus 2x squared plus 2x plus c. Now in this one here, I have integration of x minus 3 times 2x plus 4 dx. Now what I would suggest you do here is go ahead and multiply that together. It'd just be easier to integrate it. So when I FOIL this out, I get 2x squared minus 2x minus 12 dx. Now what I'm going to do is go ahead and integrate that. Add 1 to the exponent, divide by the exponent. Whoops, that should be a 3 right there, sorry. Minus, add 1 to the exponent, divide by the exponent. If you have a constant, you put on an x, and then you always have to put a plus c if it's a indefinite interval. Now, I know it's indefinite because I don't have numbers here, and we'll talk about that later. So my final answer here is 2x cubed divided by 3 minus x squared minus 12x plus c. And the third one, notice you're integrating 3 over x to the 5th dx. Now what I suggest that you do is you go ahead and bring that x to the 5th up to the numerator. So you're integrating 3x to the negative 5 dx. What do? We add 1 to the exponent, and then we divide by the exponent. And don't forget to add that c on the end. Now what you want to do is rewrite this without a negative exponent. So you end up with 3 over negative 4x to the 4th plus c. Now let's just write that a little bit better. Put a negative right there. Number 4. Let's get rid of the radical and write it as a fractional exponent. So I have x to the 3/7 dx. What I'm going to do is add 1 to the exponent. So 3/7 plus 7/7 gives me 10/7. And don't forget to divide by the new exponent. So we end up with is 7/10 x to the 10/7 plus c. On number 5. It's a good idea just to go ahead and divide that denominator into all the numerators. So I'm just going to rewrite this as, now think about this as x to the 1/3, right? So this is going to become x to the 5/3, because 6/3 minus 1/3, it's 5/3, minus x to the 2/3 plus 4x to the negative 1/3 dx. Now that's what we're going to integrate. Add 1 to the exponent. So it's x to the 8/3. Oh, I'm sorry, I forgot to put the 3 here. Minus, oh, this is going to be over 8/3. Minus x to the 5/3 over 5/3 plus 4x to the 2/3 over 2/3 plus c. Now what I'm going to do is rewrite it right here. So 3/8 x to the 8/3 minus 3/5 x to the 5/3 plus, now this is going to be 12 over 2, so that's going to be 6 to the x to the 2/3 plus c. And the last one. What I want to point out here, my variable is t, so I'm going to integrate it with respect to dt. So what this is going to equal is 3t to the fourth times x to the, times t to the 1/3. Now let's add those together. I have 12/3 plus 1/3 is 13/3. So I have 3t to the 13/3 dt. Add 1 to the exponent. Divide by the new exponent. Add a c on the end. So when I simplify this, I end up with 9/16 t to the 16/3 plus c. All right, that wraps up 4.1, day 1. Let me know if you have any questions.